Hello grade 12s, welcome to my channel. Let us revise for the maths paper 2 that's upcoming tomorrow. I hope you guys find this video within reasonable time to have a look at these questions. Try them out alongside me doing these videos. So the strategy that can help you to avoid just watching passively is to pause the video and attempt the questions, then check out the solutions as I go through them, and of course try to understand where you are lacking and understand where you are gaining. We are going to use this paper from the Northwest Province back in 2016. Okay, sometimes some people may wonder why I often have the Northwest in my channel featured. I was actually born when my mother had gone to Sun City in the Northwest, so my nickname was Sun City. So yeah, you know why. Right, so this is maths paper 2 guys, for 3 hours. Please do check instructions, very important ones that have a lot of directive in terms of mark allocation. Is instruction 5. So this one says 2 decimal places, no more, no less, guys. And the second thing is, if we are doing calculations, we need to clearly show all diagrams, substitutions, you name them. What I love is this: many people ignore this part, and yet the etc. means if you've used a theorem in Euclidean geometry, it has to show up here. So if you've used, some concept from paper 1, yes, it has to come up here. If you've had to differentiate something, it has to come up here. All right, folks, I may not really keep this any longer. Please read all the instructions, of course, and ensure that you have understood everything. Now, folks, for me, the strategy that I would propose for a student who wants to pass maths paper 2 and at the same time ensure that they finish, since many of you struggle with Euclidean geometry, this would be the first part. I would start here. Do all the Euclidean geometry questions while still fresh and focused, okay? The second one that you want to get out of the way is the analytical geometry section, right? You do all these questions while you're still fresh and are able to reason. As much as these sections don't have that many marks, they are quite challenging to go through. Look, then if you want to bank some time, if you really want to bank some time, this is your option to bank. This is usually an easy question. I'm going to put it green. It's an easy spot to come and bank some marks alongside question 7, alongside stats. Any question on the stats, you can just come and bank time on these questions, because you can go through these very fast, and after that you can go through the trigonometry section, which can be quite intense as well, but usually it's approachable. Otherwise, folks, we're just going to start from question 1 and go through this. So that's just the strategy I would propose to a student who wants to really pass, and pass convincingly. Euclidean must come out first. Second, analytical geometry. These are the sections that can steal your joy if you are not ready. Otherwise, the others are quite predictable and fairly easy to navigate. Now, we are told here that a mathematics teacher wants to create a model by which she can predict a learner's final marks. Okay. So the intention is to predict a learner's final mark. Right, she decided to use her 2015 results to create the model. All right, so that's the one, guys. So we can already see there, that's the preparatory exam mark, and the final mark is on the Y. So obviously this is bivariate data. This is regression analysis, which is a topic for grade 12s. Right, folks, so to deal with this question, it's very easy. First, you just don't waste time. Go to mode and then choose stat. And then from there, you're going to choose A plus BX. And a table will unfold with X and Y. It's a 2-column table. You fill it in. After filling it in, you press your AC button. What is the function there? It stores your data. Right. And then quick actions from the mode, we go to shift. Right, and then we press button number 1. It unlocks the stat function to analyze the data, or statistical analysis, you can say. Then from here, we're going to choose regression. It's reg. Okay, let's just say regression. Yeah. Then from regression, what do we choose? We can choose A, we can choose B, we can choose R. We can choose the standard deviation in terms, the mean in terms of X, can choose the standard deviation in terms of X, can choose the mean in terms of Y, standard deviation in terms of Y. That's about the things that you can do here. So folks, this must not be a tedious issue. Obviously, for those who have really studied their job, their work, this is fairly easy. Let's get to the calculator straight up. We go there, stats, and then we choose that 2-column table. So we see that we've got 55, 35, 67, 85, 91, 48, 78, 72, 15, 75, 69, 37. So we've got 12 entries here. So let's check. Are they 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is good. And please, guys, make sure your entries are good. That's just the only problematic part of this question. What makes it a little tedious is the fact that you have to double check that all is input correctly. Okay, 57, 50, 74, 80, 92, 50, 80, 81, 23, 80, 75, 42. So I can see that I've got 12 entries there. Please double check, guys, that everything is good. And then we go for our AC button, and then we go shift. We unlock statistical analysis. We choose regression. And as I said, we just go for it. Now, the first question was easy. It says determine the equation of the least squares regression line in the form y. Y is equal to a plus bx. So obviously what we need is A, we need B, and our equation. Remember, the equation has a cap. So now let's get to business. So we choose A, and A comes up as 12. Now remember, to 2 decimal places, this is as good as 12, okay? Nice and easy. We repeat the process. Go shift, stat, regression. We choose B this time. B is 0,88. Okay, so our equation is going to be 12 plus 0,88 x. Nice. No time wasting there. So you get a mark for each of these guys. Putting it together, 1.2 says use the equation of the least squares, okay, of the regression line to predict the final exam mark for a learner who obtained 46% in the preparatory examination. So this is easy. Y with the accent is going to be 12 plus 0.88. Now we just input 46 here. Right. We were not told anything though that this is marks in percentage or these are marks. You see, there's provincial papers though. They have a thing, you know, they have a thing, but obviously the final exam we use percentage, right? So we'll assume that everything is in percentage, but we should be told that these marks are in percentage, not just the raw marks. Anyway, we're gonna go with it. So we can say, therefore, y is going to be, let's see, we've got 12 plus 0.88 times 46. So this gives us 52.48. Is it 48.48? But remember, we don't want these like that. So this is approximately 52 marks. Because if we have to, remember this one we don't need. But I mean, we can leave it like this. Who cares? But it's much safer to round off to the nearest percentage here, or to the nearest whole number, since everything is in whole numbers. So you are at liberty to say, therefore, the student or the learner, therefore the learner will get approximately 52%. Some people may say, well, approximately 53%, that's still okay. Honestly, how you come up with these, remember these are approximations, they're not exact values, so there's a range of answers that can be accepted and rejected. Right. Otherwise, folks, what is important here is this and your final answer. Even if you get it, you leave it here, it's still all right. Great stuff. So let's go on, guys. We've got 1.3. 1.3 says, could you use the equation to estimate the preparatory exam mark for a learner who obtained 73% in the final exam? Give a reason for the answer. First of all, we look at 73%. Where is it? If we look at our preparatory marks, because we just need to check on the domain X. Is 73 within that domain? Now let's look, what is the minimum mark in the preparatory exam that these students got? The smallest is 15, right? Yeah, the smallest is 15. And the largest mark is 91%. So essentially 73 is within that domain. So it is indeed, this is true. We can say yes. And the reason is that 73% is within the domain of the least squares regression line. Right. Another way of explaining this is that we are doing interpolation. Interpolation. right? So if we are interpolating, it means it gives us an accurate result because we are using what is within the domain. The moment we use what is outside the domain, that's extrapolation. That would not necessarily give us a credible result. So obviously, guys, for saying yes and explaining, however you choose to do that, that's good enough. So 1.4 says show that the mean of the x values and the mean of the y values lie on the regression line. Okay, right. So we can say this, that basically this point, right, is this one here. Let's go to our calculator. As I showed you guys, the calculator does everything. Shift, stats, we regress, and oh sorry, we don't do this one. Now to get the mean, we do a slightly different option, because if we want the mean, here's the plan to get around it. So within that very same piece of data, we just go to Shift, right, and of course button number 1, we unlock statistical analysis, but this time we are going to choose the what you call variance. Is it the variance? Yes, we choose the variance. From the variance, we're gonna get our business. Actually, I kind of became careless here. These ones are the ones that we get from the variance, or sometimes it's called VAR. So essentially from regression, we get these ones. And from the variance, we get standard deviations and all. So we're going to say Shift. Then instead here we go to the variance. And can you see we get the mean of the x values. So this one tells us this is 60. Comma 58. And what is the mean of the y values? We repeat the process. The only problematic thing here is that you keep going back and forth, unfortunately. But hey, it is what it is. So this gives us 65.33%. Now folks, to show that this point lies on that regression line, we just substitute the point. So if we do so, what happens? So in this line, y equals 12 plus 0.88 x. So what we do implies that 65, not 56, 0.33 is equal to 12 plus 0.88. Oops, I don't know why I'm doing things in a very strange way. So let's see, is the left hand side, so 65.33 is equal to, let's do this. So the nice thing is that this is 12 plus 0.88 into 60.58. Are we getting the same thing? More or less. So we're getting 65.31. So obviously if we just round off to the nearest integer, so this is somewhat, they are almost equal. So we can say therefore 65 is equal to 65 because the decimals are insignificant. We can say therefore the point lies on the regression line. right? So that's essentially how easy this is, guys. So what was important here was just to know how to get around business. So once we get this one, we get here the mean. We get the mean in terms of the y values. We get the standard deviation for the x, standard deviation for the y values. And yeah, that's the main stuff that we can get here. Okay, so this one was 4 marks, guys. So you get a mark for each of these. Nice. For substituting the point into the equation and to showcase that indeed the left hand side is equal to the right hand side. Perhaps the best thing to do here would be to even say the left hand side is approximately equal to the right hand side. Perhaps, I mean, there are many ways to make up conclusions that would make sense. Either way, 4 marks in the bag. So 1.5 says determine the correlation coefficient. Again, we go back, just use the calculator, shift statistics, we go to regression and we choose R, the correlation coefficient. So this one is coming up as 0.98. This one is a coefficient, so it does not have a unit. Easy, 1 mark. So 1.6 says describe the correlation between preparatory and final exam results. So we can see, guys, this is a very strong positive linear correlation. So this is a very strong positive linear correlation. As you can see, effectively, if we round off to 1 decimal place, this gives us 1. So that's why this is very strong, and it's positive and it's linear, because we're dealing with linear correlation here. So obviously, guys, for this proper description, you get nice full marks there. All right, so that was a bit of a warm-up, you can say. Of course, guys, answer this question within the first 10 minutes. Do not go beyond 10 minutes answering these kinds of questions. But for me, I have to explain a bit, so I take double the time, right? Second question. Second question says, the table below shows the results of a survey of cell phone expenditure for 100 learners from a secondary school in Rustenburg. And there we see expenditure in rands from 50 rands to less than 100. There were 24, and you can see there is a missing value. Okay, cool. Right. Now let's see what is cooking here. It says determine the value of A. So this is easy, guys. You just take the frequencies, remember, must be the total frequencies must give us 100. So we're going to say 100 minus 4 minus 14, right, minus 52 minus 24. That gives us 6. So this is a 6. So however you do this, guys, so we can just say A is equal to 6 learners, right? Is it learners? Yeah. Man, come on. My writing just gives me problems. So we get 1 mark. 2.2 says, complete the cumulative frequency table in the answer book. Very easy. I will do it here. So obviously this one is going to be 24. You let it through. Then we add the 24 to 52. Then we get 76. Right, and then we add the 14 to the 76, gives us 90. Then we add the 6, we get 96. We add the 4, we get 100. Obviously, once the last cumulative frequency matches the total of the people, we know we did well. So we can just say C table. Right. Okay, we get our 2 marks there. So 2.3 says, draw an ogive or a cumulative frequency graph for the data. Very easy. Now let's just do some things. Okay guys, so we've got our grid ready with the graph paper. Now what are we doing here? We have to do the ogive. Remember, when we draw the ogive, we always take the top boundaries of each class, isn't it? And we draw them against the corresponding cumulative frequency. It's as simple as that. Okay, so we can just say this is the cumulative frequency graph, or we can say this is the ogive. Okay. So always give some label of what this is. Don't just draw a graph. Now folks, we don't necessarily have to start, you know, from, I don't know, so we need 50, 100. Yeah, we can go in 50s. This is good. So let's see. You can say 50, 100, 150, 200, 250, 300. So this is even bigger. Okay, maybe let's make it interesting and say this is 50, this is 100, 150, 200, 250, 300. Oh Lord. Okay, let's leave it here. So 50, 100, 150, 200, 250, 300. I think that's better. Oh Lord, I actually did the wrong thing. No, this was meant to be on the x-axis actually. So this is for the x-axis. For the x-axis. Right. Now, okay, so what we need is to make this one a bit longer. Great, so the y-axis, I'm wasting time now. This is just the annoying part of this thing. It really forces you to waste a bit of time drawing. So you must be efficient in doing this. So of course, guys, we see that we are starting from 24 all the way to 100. So we can just say 20 by 4. Is it by 5? 1, 2, 3, 4, 5. So this is 20, 40, 60, 80, and 100. Okay, let's move it down a bit. So make sure the graph is good. Right. So we can just say 20, 40, 60, 80, 100. Okay, so that's good. So this is the cumulative frequency. That's the number of people. And this is the expenditure. This is in rands. Okay. So we are good. Now, folks, this is going to be our 0. Okay, 0. Of course, this is going to be 50, 100, 150, 200, 250, 300. So this is good. Now, folks, let's plot. Let us plot. So what do we have? We see that 100 goes, or first we anchor. So we'll anchor in the lower boundary of our first class. Now the top part, it's 100 goes with 24. So this 100 here, this one should be on the line. 100 goes with 20, 22, 24. 24 should be around here. Right, and the next one, we've got 200 going with, no, 150, excuse me, 150 with 52. So this is 50 in the middle, and 52 should be somewhere there. Okay, good. Next one, 200 goes with 14. Sorry, what am I saying? Wrong. Excuse me, guys. Reading in the wrong spot. Now, 150 with 76. Excuse me. 70 is over here. So, 76. Somewhere there. Okay, good. And then 200 went with 96. So this is 90 over here, 96 somewhere there. Okay, 250, 96. 90, man. 200 with 90. Lord. Okay, that should be 90. 250, 96. Okay, guys, I'm losing focus a bit. I don't know why. 300 goes with 100. So we can already see, guys, the ogive comes up nicely. So we just join. Remember, this thing has to be S-shaped. Right. Sunpapela. Mosuku papa kevwe naman. Okay, let's do it again. Good. If no one papela. So there we are, guys. We've got an S-shaped type of thing, and it looks nice. It's anchored, and we can see the plots. So the shape is reassuring. So how do we score marks there, guys? We get a mark for the shape. It must be S-shaped. And we get a mark for anchoring it. Knowing where to anchor is important. And the rest of everything. Labels properly put. And yeah. Nice and easy, guys. No questions about this one. So 2.3 says, 2.4, excuse me. 2.4 says, what is the modal class of the data? Now, obviously, the modal class or class is the one with the highest frequency. That's the one. So that would be the modal class. So it means X must be less than 150, but greater than and equal to 100. So that's the modal class. But how would you know from the cumulative frequency graph? You just focus on the one with the greatest gradient. So if you draw a tangent here, you will appreciate that the tangent is very steep compared to the tangent there and compared to the tangent there. So the one with the steepest gradient is essentially the class. That's the modal class. Okay, so I hope that also makes some sense. So you can either use the ogive or the frequency table. Nice thing is it's answered, guys. Now folks, with this question, this is all nice, this is good. We don't want to say too much, but let me say something. We need to consider some additional questions here. They love to appear, just so that we can complete our revision in this. The usual and very common question is to find the estimated. Find the estimated median expenditure. Okay, let's just say find the estimated median expenditure. That's just the key thing here. So how do we find that? Of course, guys, we just go there to our cumulative frequency graph. We want the midpoint. The midpoint is at 50, so we just take it to the ogive, right? And from the ogive, we take it down. So we take it down to the x-axis. And that's just how we estimate the median expenditure. This is a common question. So when it comes, you come and read it here. So this is from 100 to 150. So this is 125. So this should be around maybe 125 there. Maybe we can say maybe around 106, 110, around there. So you can say this is approximately 106. You can say to 110 rands. Of course, this is a range of answers that is expected, but you're not going to write a range, okay? You're just going to choose one, either this or that. Okay, good. I don't know why I wrote with this. Maybe let's just commit to one. So we know that this is going to be 106 rands. And of course, here the answers that can be expected, maybe we can say 106 or even 105 to 110. Yeah, I think so. So obviously, guys, this was just a question that we are creating, which is sometimes very important. Now, the other question that is common in this question is to calculate the estimated mean expenditure. Right? Calculate the estimated mean expenditure. Okay, let me write better. I don't know why I always write in this manner. Anyway, calculate the estimated mean sometimes if okay, there's nothing I can do about it. Now folks, the procedure to do this is very interesting. So we will write here, this is going to be the mean, here is going to be the sum of is it what konje x ne daily bala getana times frequency kanene, yeah, all divided by their number. Now what is important here folks is to expect this to be the case. So let's see, we add all the midpoints and we multiply them by their corresponding cumulative frequencies. So the midpoint of 150, so we just say 150 plus 100, that gives us that, we divide it by 2, it gives us 75. So for this one, please be able to do this one, this is 75. Here we get 100 plus 150, we divide it by 2, gives us 125. And you can already see the trend here. From 75 to 125, we added by 50, right? So from there, right, and then we add another 50, it should take us to 175. But again, we can check and say 150 plus 200, that gives us that, divided by 2, it's 175. Then you just keep adding 50, this is going to be 225. Then 50, this is going to be 275. Okay, good. So these midpoints, guys, we then multiply by their corresponding frequencies and we add all of these up. So the first one is 75 times the frequency plus the next one is 125 times the frequency 52 plus we're going to have 175 times the corresponding frequency 14 plus 225 times 6 plus 275 times 4. And all of this is going to be divided by the number that we have here. So how many learners do we have? 100. So the total number of learners or the total frequencies, that's the one that we're going to put there. And of course, let's just move everything up a bit so that we can have enough space to write our answer. Right, superb, superb, superb. Right, so let's move you. Great, so this is the answer, guys, that's expected. So we will have 75 times, go to computing mode. So 75 times 24 plus 125 times 52 plus 175 times 14 plus 225 times 6 plus 275 times 4. Of course, guys, here I'm not interested in necessarily getting a correct answer. For you, it's just to understand that this is 132 rands. Remember, this is the expenditure. So every time we say estimated, it estimates on the X. We don't estimate on the Y. Okay. Everything is all about X. Okay. Please remember that. So folks, these are just the easiest and the most common questions that get asked in this topic. As you can see, I've taken 40 minutes or so, but for you guys, you should be done with this in under 30 minutes. These two questions must be over in under 30 minutes. Please don't go beyond that. Even you can do this in 20 minutes. These two questions should not take you longer than 20 minutes to actually do in the exam. All right, folks, so let's get to the next question. So question 3 says, in the diagram below, A, point in the first quadrant, B, a point in the third quadrant, C, a point in the fourth quadrant, are vertices of ABC. Okay, we can see that. AD is drawn perpendicular to BC, so it's an altitude. Sometimes we can use the word altitude instead of saying perpendicular. Altitude. On BC, if we like. Right, so get familiar with the mathematical terminology. So folks, we look at what we are given. What can we do with it? Well, we've got 2 points. We can find the gradient, which can help us find the angle of inclination. We can also work out the equation of this line. That's about what we can find. Second, on AB, we've got 2 points. We can find its angle of inclination from its gradient and work out the equation of this line, which can help us read off the y-intercept, and we can work out the x-intercept. So that's what we can do. Of course, not forgetting the distances. We can also calculate the distances. Again, we've got the line BC. We've got 2 points. We can find the gradient. And from the gradient, we can actually find the equation of this line, and we can read off the y-intercept. That's about what we can do. Now the question comes, how will we find the coordinates of D? Now, this is very important. We can use the equation of this line, right? From that equation, since this is perpendicular, we can take the negative inverse of its gradient. It would be the gradient of AD. We use point A to find the equation of this line AD. Then we solve simultaneously at this point. So we essentially can do everything. So always do this before you answer any questions. Sometimes skim and scan through these questions because you don't want to find yourself picking the wrong battles. Calculate the length of BC, easy. Equation of BC, easy. Equation of AD, we have a plan. Determine the coordinates of D simultaneous. Can you see these two help us? Calculate the size of BAD. This one. So if we want this angle, so that one is going to require us to work out some magics. But the nice thing is we will have the equation of AD, which gives us the gradient, so we can find this angle of inclination of AD, as well as we can find the angle of inclination of essentially, what is that? Of AB, yeah? So from those, we now see that we can slip into this triangle. If we slip into this triangle, we can use the exterior angle of a triangle to work out things. So folks, sometimes you think fast and you think ahead. Try to simplify your life as you go so that you don't slow down and struggle to figure out. So we can even name these angles. We can call this one beta. We can call this one alpha, right? So that we can work nicely with those. And then again, it says calculate the coordinates of point E if the area of BC. Obviously, there's always a higher grade question, which don't even waste your time. Now, you know, more answers can come from this. In fact, we have all those marks in the bag. How many? 8, 11, 14, 16. So can you see? We've got 16 marks in the bag. Even if we don't get that 4 marks, we don't care anymore. So this is where we bank some time and marks. So 3.1 says the length of BC. Easy. BC is going to be the square root of the x at C minus x at B all squared plus y at C minus y at B all squared. So this continues nicely like that. So let's see. X at C is 6. Minus x at B is going to be minus 3, which is going to be plus 3. All squared. Y at C is minus 5. Minus 2 all squared. Can say therefore BC is, now let's just get it done quickly. So I've got 6 plus 3. Sometimes with these ones, because they are quite complex, use your calculator effectively to not waste time. Otherwise, you could do this in your head. So this gives us 3 root 10 units. Okay, easy 2 marks, substitutions, and correct answer. But remember, the substitutions have to be into the correct formula. Okay, so 3.2 says, determine the equation of BC. Very easy. We want the gradient of BC first. Gradient is going to be y at C minus y at B divided by x at C minus x at B. So y at C, this is minus 5 minus 2, going to be plus 2, divided by 6 minus 3, it's going to be plus 3. So now what we have here, guys, is minus 3 over 9. So this is minus a third. Okay, go through the steps nicely, don't rush. We can say then, we know that BC as a line is going to be y is equal to minus 1 over 3 x plus c. Now we've got any of these points, we can choose B. Minus 3 is to minus 2. Again, folks, make sure you are the one who ensures that the answers are correct, the substitutions are correct. My job is to show you the method more than to get the answers right, okay? Please don't hang up too much on me being correct, but rather the method must be the correct one. Now, we can already see, folks, that we've got a situation where we've got just 1. Transpose 1 becomes minus 1. So we can see that our C is minus 3. That makes sense because it's a negative. It's quite far from the origin. I'm surprised it was not indicated. Bad stuff. So therefore y is equal to minus a third of x minus 3. Okay, guys, so this is good. So obviously substitutions, gradient, substitution, answer. This is usually 4 marks, so we're only getting 3 marks. Interesting. So it means you're not getting a mark for the substitutions. Anyway, whatever, guys. Sometimes life is not fair, hey? Right. So we've got that one in the bag. So we need the equation of AD. So this is 3.2 0.3. So obviously, folks, we know that AD, maybe let's state it first and say gradient of AD multiplied by the gradient of BC, we should get -1. We know that AD is perpendicular to BC. That's why. So we can already see therefore that the gradient of AD should be just 3, because it will be the negative inverse of that one, or the negative reciprocal. Great. Now that we have it, we can say therefore AD as a vector is going to be y equals 3x plus c. We've got point A, which is 4 and 5. This means 5 is 3 into 4 plus c, therefore c. This is 12 transpose, it gives us -7. So we can easily see that y is going to be 3x minus 7. Again, nice and easy, guys. So getting the gradient is important. Substituting the point, getting the equation. Nice and easy. So you can see, guys, here you can bank some time and marks here. So let's see, 3.4 says, find the coordinates of D. Can you see? Easy. D is such that 3x minus 7 is equal to -1/3 of x minus 3. We already saw that we need to solve simultaneously. This implies we can multiply by 1/3 throughout, so we can get 9x minus 21 is equal to -x minus 9. Right, so we move x to the other side. This means 10x is equal to -21. In fact, 21 minus 9 is 12. So this gives us 12. Therefore, x is going to be 6/5. All right, that makes sense. It's not far from the origin on the x-axis. So that's good. So y is going to be, let's use the easiest. So this is 3 into 6/5 minus 7. Therefore y is, let's check. So we've got 3 into 6/5, that minus 7. So this gives us -17/5. So what value is this? This is 3,4. Okay, that's fine. It's below the y-intercept of our line. It's below the y-intercept of our line BC. So that's not bad. 3.4 is indeed less than 3. So that's sensible. So remember, guys, this thing said coordinates. So let's do it. So therefore D is the point 6/5 is to -17/5. Please present the final answer as the ordered pair. Or if you don't want, you can just say x at D, y at D. Then you don't need the ordered pair. Okay, so it depends on how you approach the answers, but try to always present the point like this. Okay, folks, the method matters, and then the x and the y. However else you do this, it's your own problem. Nice and easy. Can you see, guys, we're not losing time here. We're not losing time at all. Now the second question, 3.5. says we want that size of BAD. So now we've got a plan. Well, we're going to say find let alpha be the angle of inclination of AB and beta for AD. Please don't just show up with alpha and beta that we don't know. Introduce it, guys. Just be clear in life. Learn to communicate properly, because these things are going to help you even at work. You will not be beating about the bush to get the message across, and you will consider things that can create controversies. So this is to try and get that brain, to try and clarify things so that it's easy for someone to follow without needing to have practiced this beforehand. Now folks, with this, what are we going to do? Well, we know that tan alpha is equal to the gradient of AB. So this implies that tan alpha is the gradient. This time we've used a formula above. There's no need to do it. If you know how to do it, please do it well. But if you don't know, this is 5 minus 2 is going to be 5 plus 2. Therefore, this is going to be 4 minus minus, like that. So this implies that tan alpha, you can already see this is 7 over 7, it's 1. So folks, we can say therefore, or perhaps this implies that tan alpha is alpha, not tan alpha. Therefore, this implies that arctan of 1, therefore alpha is 45 degrees. Nice and easy. You can say likewise. What do we know? We know that tan beta is going to be the gradient of AD, right? So this implies that tan beta is equal to the gradient of AD. We know that it is 3. So this is 3. So we can say this implies that beta is going to be the arctan of 3. Therefore, beta is shift tan of 3 gives us 71, comma 5. Now this one, always try to preserve the decimals so that they don't give us a headache. Now we answer the question. Then we know that essentially alpha plus BAD is going to be equal to beta. This is the exterior angle of a triangle. At this point, we don't care to name it. It was not named, but we are using the concept. So what do we have for alpha, guys? 45 plus BAD. This is equal to 71,565 degrees. Therefore, BAD is equal to, now we take that answer, we subtract 45. Okay, this one doesn't really affect our answer that much. So we get 26,57 degrees to 2 decimal places. Remember, the general instruction was quite clear on this. So folks, what is the story here? These 5 marks are quite nice in that we had to find the gradient of this point. So this is nice. So 2 marks for that. 1 mark for this. 1 mark for the statement and reason. And we get the final mark. Okay, easy 5 marks. Nothing complicated. Can you see, guys, we didn't lose so much time at all. Now we are on the higher order question. 3.6 says, calculate the coordinates of point E if area of triangle EBC, EBC is equal to the area of triangle ABC, and E is a point on the positive x-axis. Okay, cool. So we can just decide to place E somewhere. Okay, so let's just say E is over here. It can be anywhere, guys, but this thing will correct us if we are doing a big mistake. And of course, if that's the case, we were told that EBC, so we just complete the triangle. So we've got triangle EBC. So that's the triangle. We've got it. And we've got triangle ABC. Okay, cool. There's that overlap and stuff. Now we are told that these triangles have equal areas, but do you realize that they have the same base? They have the same base, BC. And for ABC, the perpendicular height is AD. Okay, cool. So with two triangles that have the same base and they have the same areas, what does it mean? It means they have the same heights. So this already tells you and I that EC must be equal to AD, whether we like it or not. Otherwise, there's no sense in this. So if two triangles have the same area and already they have the same base, it also means the height must be the same for the both. Okay, so cool. So what does this mean, guys? If this is the case, it already tells us something that, hey, look at this. If we join AE, what should we see? When we join AE, of course, we're not really saying it's there, but we are just imagining it there. Even these ones, we were imagining them there. Right. Now, folks, what can we say? Look, if these lines are the same, it means this line must be parallel to that, isn't it? Yes. Why? Because if you remember in Euclidean geometry, when we prove the proportionality theorem, what do we say? Those triangles have the same base and the same height between the parallel lines. So this is the property that we can explore at our, at our leisure, if you will. If you will. So there's plenty of ways, of course, we can do this, folks, but this is just the way it is. So one can explore the fact that the two lines are parallel, right? Meaning this must be parallel to this. Or we can just simply say this length, we can say this length must be equal to that length. So we've got all these things, and mind you, point E has an x value that we don't know, but if it is on the x-axis, the y value is 0. So we can use that. So there's plenty of ways to go about this, but what is important is to realize this, that if they have the same base, they have the same area, they must have the same height. Now you can either explore the fact that AE must be parallel to BC to suggest that they have the same base and they must have the same height between parallel lines, understanding Euclidean geometry. And or you can just say if they have the same height, I will just say EC must be the same as AD and solve using the distance formula. So here you've got options, guys. And as you can see, this one is going to steal a bit of your joy of saving time, but we were saving time so that we can complete this question. All right, so obviously, folks, we can just easily say, well, ED or EC must be equal to AD, right? We can say these ones have the same base, triangle EBC and triangle ABC have the same base and same area. So they must have the same height. Same base and same area. Therefore, they must have the same height. There's no stories about it. Okay, so let's go for it, guys. So this implies, now remember, we don't like square roots here. So this implies that EC squared must be equal to AD squared. Again, these are the gymnastics you learn in Maths Paper 1. You can square anything that's an equation. Square the left-hand side, you also square the right-hand side. Just setting up the mood nicely. Now, EC squared is going to be x minus 6 squared plus 0 minus 5 all squared equals AD. Now, we've got the coordinates of D. So, AD squared is going to be basically the x at, say, A, which is 4, minus the x at D, which is 5 over 6, is 6 over 5, excuse me, all squared plus the y value there is minus 17 over 5 minus I don't know what I'm doing now. I'm doing the wrong thing totally. The y value at A is 5 minus, then it's going to be minus 17 over 5. As you can see, guys, it's easy to mess up if you're not careful. So this is going to make us go home. Please don't expand this bracket. There's no need. This is going to be plus 25 equals. Let's just evaluate everything on the right. So we've got 4 minus 6 over 5 all squared plus, we've got 5 plus 17 over 5 all squared. So this gives us a 392 over 5. Nice and easy. So we go on. So x minus 6 all squared equals, transpose the 25, so just minus 25 there. So we get 267 over 5. Right. Now, this one is cool. Yes. But in any case, guys, I think this one would definitely not work in our favor no matter what. So our job is just to take the square root. Whether it's nice or not, we just take the square root. We do our things. We will check this and see if we're going to get the same answer. Now let's have a look, folks. What sayest thou? But I was hoping for something better now. Yeah, I was hoping for something better. And I'm not getting anything better, so this implies that x minus 6 is equal to, now what is that? So square root, answer 7,31. Okay, cool. Now let's do it. Remember, this is plus or minus, isn't it? Yes, on the right hand side. Take care to do that. But now we are only looking for the positive answer. So we can just say, therefore, x at E is going to be 7,31 plus 6. So this gives us a 13,31. And what were we looking for? The coordinates of E. We can say, therefore, E is the point 13,31 and 0 because it's on the x-axis. Okay, as you can see, guys, once you know, you know. And don't be alarmed by the fact that the diagram doesn't look representative. Remember, this is not drawn to scale, so it must not sway you. Right, folks, this is very important, and the reason somewhat makes some sense. And of course, folks, what matters here is the substitutions on the left, substitutions on the right, and giving us the point at the end. We smile our way forward. Now, folks, these questions you either attempt on the go or you attempt a bit later. The other way to approach this, as we said, we have to consider some options here. So the other way to approach this question would be to use the property that AE must be parallel to BC. So first and foremost, we're just going to say AC must be parallel to BC. Why? We can say triangles have same base and same area. And so we'll have same height between parallel lines. Right? So that's the idea of saying what we are saying. All right, so now what do we know, guys? This implies parallel lines have the same gradient. So we know that basically MAC, not AC, but AE must be equal to MBC. Isn't it? Parallel lines have the same gradient. This one, we're going to say not X, but we're going to have 5. Okay, let's say 0 minus 5 divided by X minus 4. This is equal to the gradient of BC. We got minus a third. Okay, at this point, we don't really care about other things. So we got minus a third. Now, what do we do, guys? Eunomos. So this implies that we've got minus 5 over X minus 4 divided by minus a third. Cross multiply and get the things in order. So minus 1 times that is going to be minus X plus 4 equals, this is going to be minus 15. So minus X is going to be equal to minus 19. Ha! Hey. Hayi, isingibhidile heke manje. Isifuna ukuthini hike manje. Therefore, X must be equal to 19. Therefore, E is the point 19 and 0. Hi. Hi. Ayisenzanga yonke lento besiyifuna. Why is this answer not coming up? Did we make a mistake? Maybe. I'm feeling like there must be a mistake in my calculation above. These cannot disagree, eh? They just can't. They just cannot disagree. And this is by a huge margin. Okay, let's just double check. EC, it's going to be X at E minus X at C. Okay, that's fine. All squared plus 0 minus 5. That's cool. On the other side, AD must be equal to AE. Okay. Now here's the problem with this approach. Nobody said EC is perpendicular to BC. So that's why it didn't work. So it looked all smart, but after all, a bad idea. So I cannot safely say AD is equal to EC because there was no mention that EC is perpendicular to AD. So I can see why. So this approach is actually wrong. Okay. Again, it was not too bad. Let's just imagine you did all of this. You'll probably get 2 marks for trying. Yeah, but this one, it's bad. Okay, it's bad. So at times, guys, can you see a second approach actually alleviates a mistake that you might be making, because it's easy to make this mistake thinking you are doing the right thing. So now this is no longer an option, but rather an approach. Okay. So anyway, folks, during practice, you make sure you play a long game, okay? During practice, you play a long game. Right, so this is stealing a bit of our time, as you can see. And unfortunately, guys, these are the questions that it's either you do or you don't, right? Because they will steal time. That's why you want to bank time on easy questions. So obviously, guys, this statement and reason is quite powerful. And this business is good as a result. And we can say the substitutions on the left hand side here, and showing us the coordinates of the point. Okay, so that wanted to steal our joy a bit. Let's leave. I wanted to add an extra question, but it's going to waste our time. Let's get to question 4. Now question 4 says, in the diagram below, O is, of course, the origin, and N has 2 and Y are 2 points on the circumference of the circle with center M. The tangents at O and N meet at R. So we know that from the point of tangency to the common point of origin, these 2 tangents must be equal. Tangents from the same point. Nice and easy. And if we construct radii from the points of tangency to the center, those are going to be perpendicular to the tangents. Nice. So obviously these are easy things, folks, that you don't need a second invitation to express. Okay, please. And we can already see that RNMO is a cyclic quadrilateral. Why? Because the opposite angles are supplementary. Right, and in particular, this is a kite because this is the radius, this is the radius. So when the 2 adjacent pairs are equal, that quadrilateral is a kite, undisputed. Okay, cool. Let's get to business. What can we do with this? Now, always ask yourself that question. What am I going to be able to do? Usually, with this question, you're not given enough information. Sometimes you let the questions lead you on, but try to think of a plan. Okay, we have 2 points on MO. So the origin is a point, that is a point. So we can find the gradient of the radius here, and we can relate that with the gradient of the tangent. We can find the equation of the tangent. Right, that's the first thing. Second thing, once we have this length MO, that is the radius, which is going to be equal to that. In essence, we can find the equation of this circle. Right, so that's the main thing. We can find the equation of the circle. Then once we have the equation of the circle, we substitute 2. It will give us the corresponding y value. So we can find that point. And now that we know that point, we can find the gradient of this radius. Using the perpendicular relationship, we have the gradient of Rn. Using point n, we can find the equation of n. And from the equation of n, they meet at R simultaneously. So we can solve simultaneously to find the coordinates of R. So essentially, we are in a good position. So this one is a good question because we literally can do much in it. Determine the equation of the circle. Obviously, we want the radius, but we can even leave it alone. We know that the circle center M is such that x minus the x coordinate at the center all squared, x minus the y coordinate at the center should be equal to r squared. Now we've got the origin. So what do we have? We know that 0 minus 4 squared plus 0. I don't know why I put x there. This is y, excuse me. 0 minus 2 all squared is equal to r squared. Therefore, r squared is, this is 16 plus 4, that's 20. So we can say, therefore, the equation is going to be x minus 4 all squared plus y minus 2 is equal to 20. Nice and easy. Many students forget the origin is a point. Right, so writing the equation in that format, substituting this business and writing our equation eventually in standard form. 4.2 says calculate the value of y. So from the equation, we know that n is the point 2 is to y, such that we see 2 minus 4 all squared plus y minus 2 all squared is equal to 20. So this implies that y minus 2 all squared plus, this is 2 squared 4, right, is equal to 20. So it means y minus 2 all squared is equal to 20 minus 4, that's 16. Now we can take the square root. Always avoid the expansion here whenever possible. So this implies that y minus 2 is equal to plus or minus 4. But remember, we are only interested in the positive y value. But in any case, what would have been the other one? It should be, oh yeah, no. I would have made a silly mistake. Remember, the other y value is such that we continue with this line. So what this does, it gives us its mirror image on the circle like that. So do you see, it would have given us this other point here. The y value that you would see is this one over there. So always it makes it a point that the one that's the mirror image of that about the center would be the one. Okay, so obviously guys, we can say therefore y here is 4 plus 2, that's 6. That's what we were solving for. We're not going to choose the negative 2 because the negative 2 would be over there. Okay, cool. No issues. So substitution of the point in there. And choosing the correct answer. Yeah, when? Why 4 marks? Sanusqela. Le a re tlwaela bianong le batla o reng? Ske la dlala so. Ske la dlala so. Maybe gymnastics, whatever. Anyway, guys, so this is going to be the y value, and we know the y value is the 1. I don't know why it's 4 marks. Maybe there's a mistake. It should be 3 marks, guys. I don't see why. I really don't. Anyway, let's just be silly and say, okay, substitutions on the left hand side. You know, sometimes substitutions on the left and the equation, gymnastics, answer. But yeah, it's ridiculous. But hey, when the examiners decide to be generous, take it and go. Determine the equation of OR. Can you see? Very easy. So we know that MOR multiplied by MOM should be minus 1. We know that the tangent is perpendicular to radius. So this implies MOR into the gradient of this one is going to be 2 minus 0 divided by 4 minus 0 equals minus 1. Please make sure you show us this gradient, because you never know if you're going to need it. So this is a half equals minus 1. Therefore, the gradient of OR is going to be minus 2. We can say, therefore, OR as a line is going to be y is equal to minus 2x, because the y-intercept is the origin. Yes, yes, yes. Nice and easy. So obviously, guys, the statement is key. This one is key. And the equation. The gradient was a means to an end. Nice. So let's move. 4.4. 4.4 says, calculate the coordinates of R. So it was coming. And of course, big marks. So you know what to do here. We need to first find the equation of we need, okay, let me think. What do we need? Yeah, we don't have these shorthand techniques to do this. We really do not have. So let's just do it the long route. So we know that, folks, M Rn times M Nm should be giving us minus 1. Same story. Tangent perpendicular to radius. And we are looking for the gradient of Rn into, let's look at this one, Nm. So Nm is going to be 6 minus 2 divided by 2 minus 4 equals minus 1. Mrn, please make sure you show this. This is 4 divided by minus 2. So this is going to be minus 2 is equal to, yes, it looks all right. And then we can say, therefore, the gradient of Rn is going to be, we know that it's going to be a half. Okay, so we can say Rn is going to be y is equal to 1 over 2x plus c through point n, 2 is to 6. What do we see? 6 is equal to a half of 2 plus c. Therefore, c is 5. Okay, that's not bad. So we can say, therefore, the equation is y is equal to a half of x plus 5. Now that we're good, we can say, well, we know that then R is such that 1 over 2x plus 5 is equal to minus 2x, isn't it? Simultaneous equations. So we move on, we multiply by 2 throughout, we get x plus 10 is equal to minus 4x. Move that to the other side, we get 5x is equal to minus 10. Therefore, x is minus 2. All right, that doesn't look too bad for minus 2. You can say, therefore, y is going to be, use the simpler one. Yeah, that's the one. So y, which is going to be equal to 4. You can say, therefore, r is the point minus 2 is to 4. That's a point in the second quadrant, and that I can accept. Good. So again, it's not too big a problem, but just that you had to find the other equation. Right, folks, this statement is important. This gradient is key. And the substitution is important. And this equation is important, yeah. And the method of simultaneous equations and the point. So 1, 2, 3, 4, 5, 6. However you want to look at this, please let it be done. Again, with this question, guys, you lose a bit of time, so that's why it's important to save a bit of time. So this one says, determine with reasons the type of the quadrilateral represented by MNRO. So we already saw what that is. It's a kite. And the reason is because the two adjacent sides, a pair of adjacent sides, you can just say a pair of adjacent sides are equal, right? That's a kite. As we can see, tangents from the same point. Yeah. Oh, I forgot. This is crazy. I can't just say this. Remember, we were just interpreting. All right, so let's say in what is this? MNRO. I was just complacent now. We need to say a few things. We know that Rn is equal to Ro. Why? These are the tangents from same point, right? Likewise, we know that OM is equal to MN. These are ready. Yes, now we can make a conclusion. We can say therefore MNRO is, oh yeah, look, you can say this is a kite. It says what type. Now there's lots of quadrilaterals, you know. We can say, I mean, a type of a quadrilateral would be a parallelogram versus, yeah, it could be a parallelogram. It could be something that is not a parallelogram. Could be, yeah, guys, this is crazy. This is a kite, I would say. This is a kite, right? The reason is that a pair of opposite sides are equal. A pair of opposite sides. Is it a pair? You can just say not opposite but adjacent sides. Let's just say a pair of adjacent sides, or maybe let's just say adjacent sides. Is it a pair? Huh? Even with the rectangle, we say a pair of opposite sides are equal and parallel. Yeah, let's just say a pair of adjacent sides are equal, whatever. Okay. Right, so another student may want to say this is a cyclic quad. That's perfectly fine, but remember, a kite by definition is a cyclic quad. Is it? Not necessarily. Hey, hold it. Yeah, it depends on the type of the kite, if it has those angles. But yeah, you could easily say this is a cyclic quad. But now, how would you prove this? You are going to talk about that angle RNM 90 degrees, 10 perpendicular to red, but we said it above. And we're also going to talk about this MOR equaling 90 degrees, again 10 perpendicular to radius. We can already see that RNM plus MOR is 180 degrees. Therefore, you say this is a cyclic quad, and the reason, you can just say this is the converse of opposite sides of a cyclic quad. Okay, so whichever you saw first, of course, this is the name of the quadrilateral. Sometimes I don't know if that would be accepted. It's a name of a quadrilateral, that is. But the type, I would believe it's a cyclic quad. But at the same time, I think whichever you want to name, as long as you were able to prove what it is, I would accept both answers. But I would lean towards this one. Because remember the language, guys, type versus name. That's two different things, isn't it? Because as I said, a kite can be a cyclic quad. It may not be a cyclic quad. All right? But that's the name of the quadrilateral. But what is the type? There's types, there's parallelograms, you name them, okay? Right. Okay. Anyway, folks, we are done with that question. Again, you can see, guys, analytical geometry steals a bit of time. Either way, folks, as I said, you get the 2 marks, no matter how you scored it. I believe the examiner here would be a bit friendly to a student, because here a student could easily be confused. But as I said, pay attention to the language used. But I see even the very examiners tend to be complacent with the language. When they ask a type, you find them giving a name. And you're like, okay, whatever. Anyway, folks, you do what you do. I'm not involved. Let's go for question 5. So question 5 says, determine the value of. Okay, this is easy, guys. Simplification. Now, we know the 3-step approach. I'm not going to preach it anymore. You guys should watch videos in the channel long before an exam season, if you really want to crack all of these kinds of questions. But if you don't, you will not watch those videos, and then under pressure in the last minutes you are going to try and fail. Okay, unfortunately, we just have to give the hard truth, guys. If you do things in the last minutes, you are just going to fail, unless God had a miracle in store for you, which is not always going to come when you expect. It comes when you least expect. Maybe the student who can benefit instantly from a single video by a chance is the one who will bump into the one that explains things to their understanding. And perhaps the exam is on that route as well. But that would take a special occasion. Okay. Say perhaps you got sick, you couldn't study on time, but now you couldn't pass up the opportunity to write. God will do something for you. But if you're a student who wasn't sick, wasn't busy doing other things, but was just lazy to do their work and lazy to find out information on time, ziyakhala kuwe, uzofeyila kabuhlungu shem, and uzisole ukuthi bekwenzeke ntoni. Let's go. Reductions. Cos of 180 plus, this is minus cos x, third quadrant. Tan of 360 minus gonna be minus 10x, fourth quadrant. Sine of 90 plus, 90 minus, this is going to be cos x, but we square it. Right, all divided by sine of 180 minus is sine x. Then we've got plus sine squared x. Okay, cool. Let's go. So we know that negative times negative is a positive. Cos x multiplied by 10x is sine x over cos x multiplied by cos squared x, all divided by sine x plus sine squared x. Okay, the magics take place. Cos x does a thing to cos x, and sine x will also do a thing to that sine x. It happens fast, guys. If you don't see it, you don't see it, né? Because once this one is gone, this is over 1, so it is itself. So sine will divide the sine. Sometimes have quick eyes. Show that you've been doing maths. You have not been goofing around. So the answer is cos squared x plus sine squared x from the square identity that is unchwe. Just one. Right, so guys, you get a mark for each reduction. You must remember this. Very important. And of course, applying the square identity. How many marks was this? 6. 1, 2, 3, 4, 5. Well, the 6th mark we can say for whatever gymnastics took place in between here. Nice. Otherwise, that's exactly how we score marks for this. So the most marks are in this step. Make sure you are strong with reductions. If you are not good at simplification, at least do the reductions. You will get 4 marks. Okay, you are already over this question, even if you can't simplify further. Okay, cool. So 5.2 says prove the identity. Yeah, right. So we've got cos. So 5.2.1, we've got cos of A minus B minus cos of A, cos of A plus B. Right, this is equal to 2 sine A sine B. All right, let's do the left-hand side. It's an identity, cos of A minus B minus cos of A plus B. We expand. This is cos of the first angle, cos of the second, sine changes, sine of the first, sine of the second, minus. Now let's put a bracket. Again, cos of the first, cos of the second, the sign changes, sine of the first, sine of the second, cos A cos B plus sine A sine B minus cos A cos B plus sine A sine B. The magics take place. This eliminates that. So those two add up nicely. So sine A sine B plus sine A sine B is going to be 2 sine A sine B. This is equal to the right hand side. Nice and easy. So easy, 3 marks there. So of course, guys, each expansion is good, 2 marks. And all the gymnastics that took place to the final answer, it's done, 3 marks. No time to waste here. So 5.2.2 says, hence calculate without using a calculator the value of this. Okay, so we've got cos 15 degrees minus cos 75 degrees. So now we have to make sure these angles look like the ones on top. So we know that cos of 15 is 45 minus 30 degrees. Right? Use special angles minus cos 75. We have to consider these two. This is 45 degrees plus 30 degrees. Okay. So we have to make sure that this looks more like those angles over there. Now we know that using that identity, this is going to be 2 times the sine of 45, the first angle, times sine of the second angle, which is 30. Right. Great stuff. So that's exactly how it went. So this is going to be 2 into sine 45 is 1 over root 2. And then sine 30 is a half. So we know that this 2 will eat that 2. So the answer is 1 over root 2. Great. Now, folks, I forgot to mention something. Always check answers here. Just plug that into the calculator and see what you get so that you can check if there's any mistake, because it happens easily. It can happen very easily. So we get this one rationalizes. It says root 2 over 2. That's the same as 1 over root 2. And if you come up with root 2 over 2, you might be giving the glimpse that A1, but of course you will have shown the steps. But even with this identity here, or this simplification, you can just choose a value for x and give a small angle, say it's 2 degrees. Put it in the calculator and see if you're going to get 1. That's how you can check, because at times it's easy to make a mistake but arrive at a nice answer only to find that you messed up. Okay, good. So folks, let's mark it quickly. So obviously this technique of showing up like that, yeah, and showing up like that, yeah, using the identity that was given, yes, and the answer from special angles. Obviously we can just give a mark here for special angles and maybe take away that and say for essentially writing that whole expression in a manner that we can use an identity is the one. But we were getting how many marks? Stolanga before. Okay, that's fine. So it means indeed what we did is doing it. Okay, no. What we are saying is the one. So 4 marks. All right. Easy stuff. So let's go for 5.3. 5.3 says, find the value of tan theta if the distance between these points A and B is that. So that's easy. Distance formula, right? Right. So we know that, of course, AB squared is going to be equal to x at B minus x at A all squared plus y at B minus y at A all squared. So this implies that we've got square root 86 squared is equal to x at B, that's 6, minus cos theta, this is squared, minus, this is 7, minus sine theta, that is squared. Now we simplify, this is 86 equals 36 minus 12 cos theta plus cos squared theta plus 49 minus 14 sine theta plus sine squared theta. Now there's lots of identity, what you call like terms, this and that amounts to 1. So we can just take 49 and add 36 and see. 49 plus 36 is 85. So let's just, 86 is equal to 85 minus 12 cos theta minus 14 sine theta plus 1 from the square identity. So already we can see that it's 86 is equal to 86 minus 12 cos theta minus 14 sine theta. So these ones are the same on either side, so when you transpose they go away. So let's see, we've got 0 is equal to, we factor out a 2 here if we want, but do we have to? No, we don't. Okay, this is going to be minus 12 cos theta minus 14 sine theta. Now we can already see we transpose the sine to the other side, we get 14 sine theta is minus 12 cos theta. We then divide by whatever we want. So now in maths you can do magics. Okay, let's do it in the next step. So we've got 14 sine theta over. Now what am I trying to get rid of is 14. And also I want to get rid of cos from the other side. So I can do this. Divide by 14 cos theta. What you do on the one side, you must do on the other. Now again the magics take place. That takes that. That takes that. And of course sine over cos, this is the tangent of theta. this is going to be minus. Now 2 goes 6 times, goes 7 times. That we are done. And nobody said we should do it in any other way, so this is cool. We are done. So again, folks, this is one of those higher grade questions. You would probably flinch when you see it, but it's quite an easy stuff here. So substitutions into the correct formula. Very important, using the square identity there. Very important. And whatever the gymnastics that led to this, that's another one. And the final answer. So easy stuff. So obviously, guys, this is the part which has many marks, and it's fairly easy to navigate. Okay, please ensure you do. So there's one question that's missing, the one of the terminal arm diagram, but I would suppose there's somewhat substitutes for that if you think about it. But yeah, I'm not gonna go through such stuff now. Let's not waste time. We are already losing. Right, folks, if you're interested in this memo that I'm giving and in the manner that I'm giving it, you have to download it in the description below together with this question paper. Again, this is a question, folks, where you can score some easy marks. So what do we have? F of x is cos of x minus 45 degrees. So what is the interpretation here, guys? This is translated 45 degrees to the right. Easy. And g of x is equal to the tangent of a half of x. So we're making this a bit slower. We are having the speed, so we make it slower. All right, no problem. And we're given the domain. We just want to cut to the chase. 6.1, use the graph to draw the sketch graphs of whatever. But we don't have it, ne? Yeah, this question paper doesn't have the sketch, so we have to get the grid. Okay. All right, so I've got my graph paper. Let's get to business. So how are we gonna do this, guys? Now you have to really know how to get things done. I think I've shown you guys how things are done here, so please, I hope you will have done yourself a favor and paid attention. So this is the origin, 0, and I can make this one 1 and that one -1. Okay, so this is 1 and this is -1. Great. Now let's decide, what do we want? This is going to be stepping at around 45 or so, because everything is going to be moving 45 degrees. So let's say 45, 90, 180. I don't like it. 90 plus another 90. It looks too small. Let's slur it a bit, but if we do so, it's going to be a bit uncomfortable. Okay, so it's a bit, guys, so this is fine. So this is 90, 180 minus 90. Okay, let me move these ones closer to the graph. Okay, so this is going to be minus 180 degrees. Okay, that's all right. Of course, guys, the grid will be much better than this. So I'm just going to use what I have right now. Please make sure the x's are labeled nicely and everything is visible. Nice. So folks, what's going to happen here? The cosine graph, remember, was supposed to be at 0. Now it's going to be happening at 45 degrees to the right. So this is going to be there. Everything shifts 45. We're supposed to have an x-intercept at 90. It's going to be 45 degrees ahead. Okay. We're going to have a minimum at 180. So it's going to be ahead. But now we are stopping at 180. So this means we're not going to get to a minimum. So this one, the last one, you go straight and substitute it directly. It's going to be 180 minus 45. All right. So it's going to be 135 at 180. And then, of course, cos of 135 is minus root 45. So, yeah. So this one is going to be 0.7, some change. So this one is here. Roundabout. Okay. Nice. And then, of course, it will cross at exactly cos of minus 45. Cos of minus 45 is 0, what? Yes. So 0.7 somewhere there. It's gonna cross over there. Maybe it's too low. Yeah. Maybe there. Okay, good. And then, of course, x-intercept was meant to be there. It's gonna be there. But I feel like my shape is not shaping nicely. One when I want to carry. Okay, so let's try. Cos of 45. Yeah, man. Okay, guys, these things can be quite uncomfortable. So 0.7, I think let's put it very close here, since, of course, it's just not doing the things. Man. Don't buy this. It was wrong. Remember, this is 0.5. 0.7 is somewhere there, man. Now I was wondering, can't Google shape yanga shape hake. Now, yeah. Now the shape is shaping. Right, and then we're going to get a minimum at 180, guys. It's going to happen at minus 135. So the minimum, so that is the point. And then we would get this one here. At this point, I'm not interested about this small point at 90, for example. It's not going to help me much. But the last one, it's going to be minus 180 minus. So minus 180 minus 45 as it is. And then you say cos of minus 225. It gives us that same shenanigan. So it goes up a bit to there. Okay, guys, so there is the graph of f. Okay, so somewhere we need to label it, but let's not rush. Now let's look for the tangent function. Now remember, asymptotes are going to be the original asymptotes divided by a half. So let's see, we were supposed to have an asymptote at 90. So we divide this by 0.5, it gives us 180. So this means here we're going to have an asymptote. All right, so this is 180, guys. So asymptotes, the notation is a broken line. Great. And then where else? We were supposed to have it at minus 90. So now it's going to go backward. It's going to go backward. Right, so that one is doing this. Okay, cool. So those are the two asymptotes that we are expecting. Now what is it, guys? Tan of 0 is 0, so we will have 0 here. And you can already see what's happening here. What does the tan function normally do? Yeah, it was supposed to be doing this at 45, so it's going to be 1 at 90 and minus 90. So you can already see what this graph is doing. Right, guys, so those are the two graphs, and you can appreciate that this is G and this is F. Okay, so that's cool. So we've got those two graphs. Now the question is, are those graphs intersecting at 45? I doubt. Or anywhere in between? I doubt. The shape is not saying it, but it's possible. But anyway, folks, I am trying to think now. Let's just see at 45, what would be the value of, okay, maybe at 45, not much, but let's see. It's gonna be undefined, is it not? Yeah, tangent of 0,5 times minus 45. All right. Yeah. Not, yeah. That's the one. It gives us minus 0,4. So where we're cutting, we are good. We're just before 0,5. Let's see at 90. Tangent of 0,5 times minus 90. I just want to check something. It gives us exactly 1. And our function is not at 1. So chances are as hlangan. Anyway, we will assume that our sketch is good. It looks like there's indeed a visible gap. I was just worried about that part, okay? But it's not a big deal, guys. It's done. So we get a mark for each graph's shape. 2 marks. And of course, intercepts for each 4 marks. And then the 2 asymptotes for the other one. Done and dusted. 6 marks in the bag. Yeah, for you. Let's go for another one. 6.2 says, I use the graph to answer the following questions. Write down the solutions of cos of Dondoni is equal to 0. So we can already see we've got 2. So x is equal to minus 45 degrees, or x is equal to 135 degrees. Nice and dandy. So it's this one right here and that one up there. Okay, cool, easy stuff. 1 mark for each. Can you see? These ones are easy questions here. Okay, we are not answering. Please make sure the labeling of every answer, guys, is good. It's easy to just be so happy everything is working nicely to lose the things. Write down the equations of asymptote or asymptotes of G. So x is equal to minus 180, or x is equal to 180 degrees. In fact, if you like, you can just say, excuse me, plus or minus 180. I mean, it's not a big deal. Again, easy 2 marks here. So 6.2.3 says, write down the range of f. We can see f ranges between 1 and minus 1. You can say y is an element, minus 1 to 1. Keep it nice and sweet and simple. Right, easy 1 mark. So look at the maximum and minimum. Okay, So 6.2.4. Can you see, guys? Here we can bank a lot of time once everything is right. How many solutions exist for the equation? I can see just one. There's only one big solution here. It's this one. They clearly cross each other there. So I can just say 1. In this domain, of course. Nice and easy. 1 mark in the back. Can you see, guys? We're just moving. 6.2.5. Says for what value or values of x is f of x multiplied by g of x greater than 0. So this one can happen if this is positive and that is positive, or negative and negative. So let's see. When is this? Now remember, this is for the same x value. So when do we see this? So folks, if you look now, you must be able to read the graph nicely from left to right, okay? Now use a ruler there. We can see that at 180, they are both negative. This one, in fact, this one is undefined, while the other one is negative. So this means that interval we can accept, so that, well, x must be greater than minus 180. Why are we not including 180? Because the tangent graph is undefined. But this one can be less than, right, 0 is not included. So less than, what is the x-intercept there? Minus 45 degrees. So we know that both graphs are essentially negative. You know, this one, the y values are negative, the y values are negative, because this is talking about y values of f, and this one talks about y values of g for the same x value. Okay, now that's the first one. Or is there any other? So if we look here, in between, this one is positive and this one is negative, so that product is not good. We can't take 0. Again, the good thing is here they are both positive, so this goes on up until that x-intercept. So we can see x must be less than and greater than 0 degrees, but less than 135 degrees. Because beyond 135, the other one is positive, the other one is negative. So that is all. That is all. That is all. Okay, guys, so this is an easy 15 marks. As you can see, once the graphs are done, of course, carefully considered in the process, we get our things. Okay, folks? So, I mean, you can get 1 mark for this, and 2 marks for the one, 1 mark for the other, because it's more or less the same thing. All right, I would have loved to add extra questions, but we don't have time on our hands. All right, guys, so let's get to question 7. So question 7 says, in the diagram below, ABCD is a cyclic quadrilateral. Well, we can see it already. It is inscribed inside a circle, or you can say there's a circumscribed circle. Right. DC is 6 units, so it's indicated. AD is 10, shown. ADC is 100 degrees, that is shown. CAB is 40 degrees, so that's fine. So the first thing says, calculate the following correct to 1 decimal place. Please don't forget the local instruction. 7.1, we want the length of BC. So how will we find the length of BC? Tell us, comrades. Tell us, tell us, tell us. Obviously, we need to be smart about business. You see those 6 marks are telling the tale. So first, we need this length. A we need that length AC. Without it, we won't be able to do much. Verstaan jy? Jy verstaan mos. Yeah. Second, we need this angle. Right? Without that angle, we're not gonna move. Then we end up in this triangle using our sine rule to find what we want. So let's start. What do we need? Well, we need AB, AC, and AC is going to come from this triangle. Right? So, and then once we use our cosine rule there, we get AC, and then we go to this using the angles, and then we use the sine rule, guys. So very easy. So this one asks both the rules that we normally would have to prove. Please envy the proofs. Please practice the proofs of the cosine and the sine rules. Plus or minus the area rule. In fact, I should have said and the area rules, because these ones are the three rules that please learn the proofs. Any one of them can show up in that exam. All right, so let's start, folks. We can say in triangle ADC. What do we see there? We know that AC squared is going to be equal to AD squared plus DC squared minus 2 times AD times DC, the cos of angle D. That's the cosine rule. So we know that, well, AC squared is equal to AD. It's 10 squared plus 6 squared minus 2 times 10 times 6 cos of 100. So we know that AC is going to be the square root of all of this now. 10 squared plus 6 squared minus 2 times 10 times 6 cos of 100 degrees. Therefore, AC, kidi tenese, kidi ing, zena, kidi tenese kampa, kidi taula. Eskabuwa ntakisa ditsibing wena man. Watla urira. Now this one is an intermediate answer. Be careful. So this one is 12, 52, 3, 5 units. Is it units? Yes. So be careful of rounding off too soon. I'm just leaving it as long as possible. Right, so that's the first thing. The second thing we can say also, we know that, folks, angle B plus angle D should be equal to 180. The reason these are the opposite angles of a cyclic quad. Right. Nice and easy. So this implies that angle B plus 100 degrees is equal to 180 degrees. Therefore, angle B is 80 degrees. Okay, that's a very important thing. We can say then, in triangle ACB or ABC, what is cooking in that triangle? We are interested in BC. We can say BC over the sine of the angle opposite that, sine of 40 degrees. Then we're going to use AC over the sine of 80 degrees. That's the sine rule. Cross multiply. So this is going to be AC. What is AC? 12,5235 times the sine of 40 degrees, all of it divided by sine 80 degrees. Therefore, BC is, let's get to business, guys, 12,5235 into the sine of 40. Please do it nicely, guys. Sine of 80. Now we can round off to one decimal place. So BC is 8,2 units. Okay, this is the essay type question, but fairly simple. If you know what to do, there's not a lot to cry about. Okay, so writing the rule, guys, is important. Usually substitutions, yeah. And we can get a mark for this, and we get a mark for that statement and reason 1, 2, 3, 4, 5, and then 6. The angle was a means to an end. Okay, all right, okay. So we go to 7.2. It says the area of triangle ABC. So that's easy. We've got the lengths of BC and AC, but we don't have this angle. So we want to use the area rule here. So what must we do? We need to find angle C. So we know that in triangle ABC, we know that angle C is going to be 180 degrees minus the sum of these ones, 40 plus 80. This is sum of 3 angles of a triangle. Sometimes move quickly when you can, but ensure that the steps are representative. You should not allow examiners to tell the markers to take you down. All right. Yep. So this is 60 degrees. Ne? Should make sense. So what do? We can say then area of triangle ABC is going to be half AC times CB times the sine of angle C in this triangle, of course. Right, so this is equal to 1 over 2 AC. What did we get? 12,5235. CB or BC is 8,2 times the sine of 60 degrees. Wow. So that is the answer over there. Trying to look at us in the face, but doesn't see us very clearly. 5235 into 8,2 into the sine of 60. That's literally 0,5. Okay, so the final answer rounded off to one decimal place. This is 44,5 square units. Okay. Very easy. As you can see, guys, time flies, but what can you do? Nothing. So let's see. This angle is important, I suppose, but the reason is not important. This one, writing the rule, is important. And the final answer. Easy. 9 marks, guys. You smile and don't look back. You smile and don't look back. Great. Let's get to the next one. Now we are on the one that you should start with, so that you know that you've scored enough marks here. So please guys, the most important here that I would tell you is that know all theorems. How must you know them? State and prove. Okay, don't tell me that I'm only going to focus on the ones that are examinable. Look, to grow your skill and the muscle in proving, just learn to prove all the others. Then you will see others are even far more challenging than others, and they make this very easy. Now complete the following statement. Can you see knowing proofs is important? The angle subtended at the circle by a diameter is equal to 90 degrees. Right? That's it. The angle in the semicircle is 90 degrees. Can you see? Knowing the theorem's implication is important. It says the angle between the tangent to a circle and a chord drawn from the point of contact is equal to the angle in the alternate segment. Or you can say angle subtended by the chord at circumference. That also could be acceptable. But again, the wording of that theorem is to say alternate segment rather, although it implies the angle subtended by that chord at circumference, which you can say, and no one is going to say anything. If they try, call me. I will handle them for you. In the diagram below, it is a diameter. Okay, now my students know, I've shown them the approach to Euclidean geometry to ensure that they don't lose marks unduly. So you interpret every piece of information step by step. If it is the diameter, for example, what does that mean? It means the angle at semicircle is 90 degrees. And can you imagine, we already used that statement there. So that's the first thing. So this means angle EBD must be 90 degrees. That's the first thing. Is there anything we need to say? Well, since this is a radius, we know that OE and OD as well as OB are radi. So they are equal. So obviously knowing that O is the center somewhat is important as well. You can see there that we are systematically interpreting information. Avoid doing it randomly. Sometimes other things you can see that there's parallel lines, you want to jump ahead. Don't do it, because there are some angles that are going to be eventually equal. You don't want to rub and all those things, so you go systematically. Right, the next thing says ED is produced to C. Right, ED is produced to C. Let's see, ED is produced to C. So, well, that one only serves a purpose of telling us that this is a straight line. So, and if at all, we would look to saying the exterior angle of triangle EBD would be D2. I mean, it's going to be x plus 90. So it's 90 degrees plus x. Okay, not really important for now. And also, California is a tangent to the circle at B. Right. So the tangent, the moment we hear that word, we get excited, because we know that the 10 chord theorem starts kicking in our face. Like, yes, I'm the one. Right, so that's the 10 chord theorem, but this angle also is equal to E. We said these are angles opposite the equal sides. All right, is there anything more? Let's see. AO intersects BE at F. Okay, we know that vertically opposite angles will come in. BD is parallel to AO. Okay, so now we have that parallel situation. So this already says, okay, CB4 must be equal to A. Those are corresponding angles if those lines are parallel. Nice. So we've got some stuff. Now we can already see that we can easily say EABO is a cyclic quad because angles in the same segment are equal. As a result, B1 should also be equal to angle O3. Maybe let's showcase this one. So Papa, stolen color. So this one is going to be equal to that one. 10-chord theorem, but because of those parallel lines, that is the case. And you can already see also it automatically gives us the angles in the same segment. So folks, once this is done like this, you then move on. So you know that you've explored each piece of the given information with a meaning in the diagram. So we're told E is X, so that's also indicated. So we know that we've got 8.2.1. This one says, write down with reasons 3 other angles each equal to X. Can you see we already found more than that? So we've got this, we've got that. Actually, we found all 3. Yeah, nice and easy. Can you see? We are done. We are simply done. You know. So we're going to say, well, we know, folks, that B2 is equal to angle E equal to X. What is this? This is the angles opposite equal radii in triangle ABOE. This is triangle BOE. All right, so that's cool. Nice and easy. Just want to be straight to the point, guys. You don't want to waste time. So if this is 6 marks, it means statement and reason, 2 marks. Second, what else? We also saw that B4 is equal to angle E and so equal to X. 10-chord theorem. Please, guys, this 10-chord theorem is famous. I've never seen an exam where the 10-chord theorem is not applied. So you might as well know the proof by heart and also know how to apply it. Okay, so that's easy. The third one, so folks, we saw it. You know that angle A is equal to angle B4, which is equal to angle X. So these ones are corresponding angles with OA parallel to DB. Nice and easy. Again, statement and reason. So easy 6 marks, guys. No questions asked. So if you can see, just to suggest something, whenever you prove here, always attempt to name the angle first, the one that you are trying to achieve, and you use the angle that's known as the one that it is equal to, so that this is smooth. Okay, right. But again, there's no harm if you don't do it that way, but rather for ease of marking. Remember, guys, you also want to simplify the work of your marker. As much as it is your right as a student to wreak havoc in their lives, because they have to read. That's what they're paid for. They have to read what you write. I hear them a lot talking about, you must do this according to the exam guidelines. They can go away and jump in a cliff somewhere. No one said those things are a must. Even if they can try, it's only because they are lazy. They just want to have it easy when it comes to marking, because they know if you can't recall a theorem properly according to the exam guidelines, then they can easily mark you down. But what if what you wrote is not necessarily nonsensical? So this is just to say, guys, we need efficiency, and we can't just have numbers there marking and pretending that they are good. They have to be good because they have to read what a student writes. Sometimes when there's no clarity, they have to consult experts. There has to be experts available. people who essentially created these papers, the quality assurer, you name them, they have to give answers. Sometimes these things is exactly the way that provides alternatives, which can be included in the government document so that we can accept more. We can't accept less, all in the name of trying to finish marking easily. You must not go and mark if you don't know the subject very well, because the idea is to read what the student wrote so that we can see if when they regurgitate your exam guidelines, you will never know whether they are fit or not. Okay, please guys. As a result, there's this NBT thing now. Yeah, you understand. I don't know, was it there during our time? I don't think so, because I mean, in those days, certain marks translated to a certain level. For example, if you score a distinction, remember that was reserved for higher grade students. You would only get a distinction if you did your subjects in higher grade. If not, then there's no distinction for you. Okay, right. And then, of course, we knew that an A plus in standard grade would somewhat translate to a C, moving closer to B, yeah? Maybe A plus a B, and then A standard would be a C in higher grade. And of course, you go on and on. So now, guys, you have been led to some kind of confusion because you think you know when you actually don't. Because most of the stuff, guys, that's here, it's standard grade mathematics. And you guys are crying, and I'm like, what is going on with you folks? You should be actually all scoring 80% and more. Because almost 80% of the questions that you're supposed to respond to are standard grade questions, guys. Honestly. But again, this already tells us that, guys, we should bring back that separation because people are struggling more than they ever did before. And remember, you don't have to do higher grade maths to really get to where you need to go. You know, as I said, if you do standard grade maths, you can score 100%, you can score 90 plus. That's an equivalent of a B, you know, for higher grade. And I mean, that's a good mark. It can get you into medical school, engineering degree, you name it. But of course, competition is tight. We need more institutions. And I don't know why the country is not building them. But looking at the way things are, most of the education is going to start to become more digital. So many people are just going to enroll with the university, but sit at home, attend lectures online. If there's a practical, there will just be designated areas near their places or in their towns where they can go and handle practical work. And then, of course, come maybe to the main campus for the exams to avoid technicalities with copying and stuff. Submit their assignments online. Nice and easy, guys. So education is about to become a little bit less expensive, I guess. But again, the tech required to achieve this might not necessarily drop the prices in terms of the universities charging, but it may certainly drop the cost of education in general, because some students have to rent places to stay because there's no accommodation, you know, food, transportation. You start to cut down on those a bit, and you get to eat the food you eat at home, so your health doesn't get compromised. University students, they tend to be unhealthy, you know. It starts there. Most of the problems, you will see that professionals in general, they tend to be unhealthy because it starts at varsity. All you do, you eat, you sit and study, eat, you sit and study. It's easy to pack weight and you become a skat. Yeah, basiskat. And often basiskat. So don't allow yourself to be the skat. Yeah, remain the way you are. But if you stay at home, guys, you eat the food you grow up eating, your brain already is familiar with how to use that energy. So for me, there would be more advantages to do this while at home than to sit at university and you are lost there trying to find yourself amongst people who really don't care about you sometimes. Anyway, whatever. 8.2.2 says determine with reasons CBE. Whew. CBE in terms of x. So you can already see that one. You see that one is going to be x and 90 degrees. So this one is just simple. It's just simple. But we still need to justify why that one is 90 degrees at least. So we can just say DBE is equal to 90 degrees. This is the angle in a semicircle. Right? That's the first thing. Remember, we were interpreting the statement before. Now we are using it. So we must still provide a justification. We can say then, we know that CBE, in fact, we don't even say then. We can say therefore, CBE is going to be 90 degrees plus x. Remember, it's B4 plus DBE. Right. So this is easy, guys. Not a big deal. Resharpie, so statement and reason, final answer. Not a big deal. So 8.2.3 says prove that F is the midpoint of PE. So we just have to prove that this is 90 degrees and it is. Why? Co-interior. Angel de Maria. Right, so let's go for it, folks. We know that F1 plus DBE should give us 180 degrees. These are the co-interior angles. We state the parallel sides OF parallel to DB. So this means F1 plus DB. This is 90 degrees is equal to 180 degrees. Therefore, F1 is 90 degrees. So if F1 is 90 degrees, you know that a line from center perpendicular to chord bisects the chord. We can now say, therefore, F is the midpoint of BE. The reason, this is a line from center perpendicular to chord bisects the chord. You don't need to say that part though. If you just say line from center perpendicular to chord, uyiqedile wakophetha uyedile shweshwe. Now let's talk. How many marks was this? 4 marks? Really? Aye man. What? This one. Then we can say statement and reason. I got the weak. 4 marks. It should be 3 marks, man. It's swag. 4 marks. Aye. The examiners are tired of examining, eh? Don't do this in maths, guys. Maths must be hard. Please. It has to be hard. We don't want weaklings claiming they know maths. No. We don't want them. We would rather not have anyone doing maths if that's the case, okay? Can't make it easy. Aye. People need to know that straight. Calculate the length of the diameter if it is further given that EB is the things. Now, if EB is the 8 dondons, so this one is doing the things, so this one is 8. So you already know, folks, if that is 8, then what is this one? is going to be 4. Using the very theorem that is doing theorem things. You see, the theorem things. And then OF, sesiyakubona now. Yasibona kuyelwa. So this is pushing us, guys, into this triangle. So we can see that has pushed us into that triangle. Nice and easy. So we're going to use our Pythagoras theorem there. Our Pythagoras theorem. So let's see, 8.2.4. We will state in triangle OFB. What is cooking there? We know that BF is equal to half BE. Line from center, or we can just say F is the midpoint of EB. We know that F is midpoint of BE. Yabon, be flexible, man. Ungabi stiff, man. Hayi man. Nina niyakuthanda uvele niqine nje sithubeni nivele nibe into eningayazi nje. Hayi man. BF is therefore 4 centimeters. Wayibona, kuyona. Let's just move it up a bit so that we don't run out of space to write. But don't do what I'm doing. Give space to things so that the separation is good. Maybe we can move this one up a little. There's enough space for it. So there is enough space for it. But we don't want cluttered stuff. There has to be a line between 2 subsections, sub-questions, to avoid this cluttering. Okay, so that's the one, folks. So we can then say, well, we know that OB squared is equal to OF squared plus BF squared. Kintate Pythagoras, this one is going to be 3 quadrat, that's so. Then BF, what is it? Hey, sting one ganin 4 quadrat. Therefore, OB is what? This is 9 plus 16, 25. Square root of 25 is 5 centimeter. Therefore, the diameter, whichever we like, the diameter is going to be 2 times 5, which is 10 centimeter. What language is this? I don't know. Don't tell me. Don't ask me. I am not interested. This one. 4. Right, guys. This is 19 marks, and you can already smile. That you see, you can do it. You see, you can do it. 9. Hi. These needs these questions. Do you see now what uhlala pha ezantsi? Awukho right, guys. Yo. In the diagram below, C is a common chord. 2 circles, yeah. So if it is a common chord, what is it? Whatever it is. There's nothing you can say about a common chord. There's no relationship between the 2 circles unless the circles are also equal. Now CD is a tangent. Now that's the language we want to hear. CD is a tangent. Masibonakalise singazoyibhuda. Soniphaphela wena man. Color that thing, man. Hey wena man, soniphaphela. Kanti ntoni nangalewe? Yaniphambanisa. Siyeke njalo. Anyway, to circle ACE at C. Wayibona. Now, the first thing, guys, is the tan chord theorem. Tan chord theorem. This angle is equal to that angle. So, libazisa. Khawuleza. Tan chord theorem. Right. That's all you can say so far. Is there anything else? No. Then we're told here, AEH is also a tangent. So sikubonile now. Yeah, masicolorish. Unganiphapheli ndiyayibona le izondiphaphela. Sendiyayibona nje ufuna undiqhela kabi. Hayi, yaniqhela kodwa ke ayinandaba. That one is also what? What is it? Tangent. Is a tangent. Yeah, sesiyayibona ke ngoku leya angle indeed must be equal to that one. See, work it nicely, guys. Work it nicely. Don't be in a hurry. Is there more that we can say? Yes, there is more. We can see that one must be equal to this one. Tan chord theorem as well. So now what do we conclude? E3 is equal to that one. So somewhat, these are parallel lines. Kitty parallel. Ribon. Onobatlaure. ACB and BDH are straight lines. Yeah, right, we saw it. And we are told further, that this is the thing. So AC is equal to ED. Okay, so they are linear and they are parallel. Ifuna uthini? Ingathi ifuna uthetha, ne? Ingathi ifuna uthetha. Masike siyilinde incokole. Ingathi ifuna ukusincokolela. Right. Now, folks, let's see 9.1. It says, prove that AB is parallel to ED. Can you see we've already done it by analyzing the sketch? First and foremost, what knowest thou? We know without a shadow of doubt that, yes, we know that C2 is equal to angle A. This is the tan chord theorem. Ne? Gqityiwe le nto sithi also siyayazi kodwa uba nayo futhi la angle E3 is equal to angle C2. Similar tan chord theorem. But now, ithina le nto we can conclude that angle A, in fact, iyalingana no E3. Ilink yazo ku-C2. Nobungangayibhali that reason. It's not necessary. Now, folks, sigqibile. Once corresponding angles are equal, we can say, therefore, AB is parallel to ED. You just say corresponding angles are equal. If corresponding angles are equal, it means the lines are parallel. Whether you like it or not, so you must just tell it. This one, statement and reason, quite powerful, but not so powerful. Well, we can say that one too, and the final reason, 5 marks. Good. 9.2 says, what type of quadrilateral is this one? Can you see if opposite angles are equal and parallel, automatically this one is going to be equal to that one and parallel to it. So it must be a parallelogram. So ACDE is a parallelogram. Why born? But write it nicely, guys. Hey, don't write these things. It's a parallelogram. Ne? We can say a pair of opposite sides are equal and parallel to each. Adar. Yabona mos. Yeah, it must also be creative kaloku. Awuzohlala uxelela uba ii-reasons ifuneka zithini. Yiza nayo umntwana esikolo. So sifuna sikuxelele yonke into. Exam guidelines. Yo. So angathi kuphela kwento engafundwa leya. Phambanisa. 9.3 says prove that AC is equal to HE over what? Okay, maske siyitrace ke ngoku. Where is this AC? Nankya. AC over CB. If this is a palm, we see must that this one must be parallel to the other one. So that's the first thing we might have to say. From that, what do we say? Sesiyibonile. Ifanele ulingana nabani? Ifanele ulingana nale. Xa ihamba naleya. Ne? Proportionality theorem, but hey, khona ezinye indaba ngoku. Wena uthathwa phi? Ovela phi? Singayi apho uvela khona. Ohlaka hayi ngwana motho. Akozwe ukayi HE, akombonise jwale. Kyane HE. Hey, re a itseba hore e ya kgonahala tabena. Haeba fela ha o tsebe taba tsa hao ha o no e bona. Wa bona HD wa tshwana le EH o kampa HE. And a tshwane le yana ke proportionality theorem in the same triangle ABH. Fela ha re shebile ka CD parallel to AH. Le ha re shebile ka ED parallel to AB. Ho tjho hore re tlo twister and turn around our triangle and then re tlo prove. Wa bona ntho tsa bona le monate fela. Ha re ye monna re tlo re ha re qala ditaba tsa rona. Re tlo re in triangle ABH. Wa bona? Name it and shame it. Wa bona? Hobaneng ha o sa etse jwalo e tlo name ebe ya o shame. O tlo ba le ditlhong ke o jwetsa. Ha ona gona le o ipata. Hobaneng e tlo o beya pepeneneng. Ha o tsebe dintho wena empa o ntso ya sekolong o batla mane hobaneng o lahlehile mos. You are lost. Don't be lost in the school. First thing we want to prove, guys, we want to say CD is definitely parallel to AH. You can just say opposite sides of a palm. Sesithethile la nto abantu besinika ikluva phayana. Then, what knowest thou? We know, without a shadow of doubt, that also AC over CB is definitely HD over high definition over DB. Udadewabo wawana. Hana le re ke mang dadobao ka Sesotho. Hana ka Sesotho ba re ke mang? Ke rakgadi ne? Ya, ke rakgadi. Ye? Ke tshepa jwalo. Ha re yeng he bo rakgadi ba rona. Re etsa jwang ha re etsa so? Wa re bona ha re etsa so? Ke proportionality theorem. Prop theorem. Right? With? Yes. CD parallel to AH. Remember, guys, if there is no parallelity there, you cannot use proportionality theorem, even if it's a nice triangle. If you don't have a parallelity, you can't use it. So it is important to state this. I've seen a reason, which makes me wonder. But anyway, I used to use that reason too some time ago. That one side parallel to the third side of a triangle. I'm like, yo, yeah, ne? Ithetha uthini loo nto? Ithethayo yona leyo nto ithethayo. Nandaba. Kuthiwa yamkelekile ebhotwe. Masiyeke khona apha ebhotwe. We've got a nice story, but, or our ring. We also know that HD man over DB uyalikana li-HE over EA. He wena. Hai, umaditaba, tla le tsona he, go mametse, o batla hore, same reason, ke prop theorem with, this time, ED parallel to AB. Now you see, HD is here, and is also here. So that means we can replace HD with this guy. Therefore, AC over CB can be equal to, if we can break this English into pieces and put it back together again like the mechanics that we are. Statement and reason. Yes. And then this one, and then this one, and the substitution, because the final answer may look too easy, but it's not that easy. That's so. I buffet 11 marks. You smile like a gangster. Yeah, you smile like a gangster. You're smiling, but you're worried, isn't it? Gangsters, they smile, but they are worried. Those maggots, they feed on dead things. They're going to be fed. Right. Okay, guys, I hate to do proofs, but counting the and can be generous because, this is a revision. 10.1 in the diagram alongside triangle ABC and triangle DEF are given. Prove the theorem which states that A equals to D. If A equal to D and B equal to E and C equal to F, then the sides are proportional. Yeah. Okay, we will say it and say 10.1 given triangles ABC and DEF such that, say the things, angle A is equal to angle D, angle B is superb, angle E, and okay, masive nje sithethe isingesi semaths ngoba sithethe isilungu samagama. We're talking the English of symbols, notation. Now what are we trying to do, Mos? We are trying to require to be proven. The English is not Englishing right. We're trying to prove that AB ababantuan DE alternating current divided by DF. You see, must it DF more, Thomas? You know those things, construction. Remember, this is a deal breaker, my students. If you don't mention this word and you are doing a proof, fair way, yo. You are killed by suicide. You are suiciding it. So you're going to place, say, G on AB such that AG is equal to ED. And H on AC such that AH is equal to DF. What? And then you join GF. As a girlfriend, you must join that one. But hey, be careful. Girlfriends are dangerous, man. Those people. Have you ever known that women are evil? Hey, women are evil, boys. Stay away from them. until you have money. Then you'll have all of them if you want all of them, right? Right. But hey, don't let it be like that. You'll just get the one you want. But that one may not be the one you want. But you may just be wanting what you have. But at least you'll get what you want, right? You don't care. We as men, we don't care if a woman loves us or not, all right? We don't care. We just want the one we want. Uyancanywa kancanywa indaba yakhe leyo nenhliziyo yakhe anike ndawo mna apho. Hayibo. Mna ayihamseyanele. Gqityiwe so-ke ngofuna kube nemali. Kwenze kuzothola lo mfunayo. Ngenjalo. Uyawuthola ongamfuni. As for bona, hayi, abantu aba bazazi bona babafunani, ndababona kudala. Bavele nje bafune kwanto nje ngathi yahamba qha, banandaba nokuthi imile. At some point wanyizawuma very soon, hayi. Aqabela bese yafa imoto ikhohlele nje ingekahambi neemeters ezingaphi, bayaphuma bahayike mntaka bam. Shiyapho. Right, so be careful. Women are evil. And we're going to mathematically prove it if we want. Now, what is the proof? What is the proof? Congruency. We're going to say in triangle ABC. Hayi man, not ABC. Superb. Ikwazi bang ABC. So bang AGH. And triangle DEF, right? Those are the ones we want to prove congruency. Now we already know, folks, that angle A is equal to angle T. That was given. Very neilwe. What does the other one say? We know that AG kaloko. Naye uyalingana. No DE. This is the construction that we made. The same as AH. Stay naye. Uyalingana no DF. Okay. This is the construction. Here one. Ufuna uthini sesigqibile. Triangle AGH. Now congruency is like similarity but parallel or horizontal. Triangle DEF. What is the reason? We know that it's side, angle, side. Okay, included angle. Or you can say spinal subarachnoid space. Okay, SAS. Ising sasa. SAS. Jwale, iring dabin. This then implies that. Konje sikhange siyenze lento lena ngilibele ukukubonisa umntwana esikolo nansi yalento besithetha ngayo. Sendiyilibele. So nanku G, nanku H. Masiyivisualize before sisifake engxakini. Right. So we know, folks, that Leon and that one are equal, and then this one and that one are equal. That one and that one are equal. Now that we proved congruency, it means this angle must also be equal to that angle, right? Right, so this means AGH must be equal to DEF. Wow. Which is also that one, right? Why? These are the corresponding angles in congruent triangles. Corresponding in what sense? They are both opposite the equal sides, right? That angle E is opposite D, but HH is opposite that angle, so they have to be. They have to be. Which also implies that AGH ke ngoku. Hey, indaba ingathinde nje. Therefore, AGH, therefore, AGH is equal to angle B, kemos. Why? Because angle B ulingana no angle E besinikiwe phaya phezulu ukuba inje yalento. Oh, sesibonile. So we can say each is equal to angle DEF if we like. And that was given, Gallo. That was given. Now, if this is the case, we now make another conclusion that GH is parallel to BC ke ngoku. Why? Kaloku the corresponding angles ngoku eziya. Yabona sesiya-corresponda ngoku. Yeah, we are corresponding. If kunje, it means kunje. Soze kuqhume ngabaswanga, right? Xa kunomsi khona umlilo somewhere. We say it, corresponding angles are equal. Okay, guys. Nice. This proof is quite nice. It's not too long. It's just technical, okay? Now from here, guys, we use the prop theorem. We can say, therefore, we know that AG over AB, be careful here, use the entire side, must be equal to AH over AC. Okay, this is the prop theorem with GH parallel to BC. Okay, now if this is the case, what do we say? We now know AG is ED. We can say, therefore, AB. Ndiqale kakubi ne. Andiqalanga kakuhle man. Damn it man. Masiqale kakuhle. Izoflowa le nto le. Ayiflowi kanje. Siqala ngo-AB. We say AB over AG must be equal to AC over AH, yeah? We can say, therefore, we know that AB over AG is equal to DE. By construction, this is going to be AC over DF by construction. Done, guys. So the proof is just proved easily. So folks, the statement for construction, whatever you say there is nice. Proving congruency here, the reason is important. Zipes marks 10 is ngabhalwanga nje. Oh, but a 7. Hi. By a piece and that one is important, yes. And this one is important, yes. 1, 2, 3, 4. Then this one is 5. Substitution 6. 1, 2, 3, 4, 5, 6. Yabona ke ngoku khona ezinye izitatement ezine-reasons ezibalulekile yaqonda. Singathi statement and reason, it's okay. Okanye size apha sithi statement and reason. Okusalayo 7 marks is in the bag. Okay, let's put it to practice bafowethu. Osesemaphethelweni, hawu kwaze kwamnandi, kwaze kwamnwebese. 10.2 says, in the diagram, pick your S as a cyclic quadrilateral, please. Check it. So that has all 4 vertices at the circumference, right? PS and QR are produced. If they are produced, it means we can showcase them like this. Same line. Of course, we are not necessarily on a coloring spree, guys. We just want to make sure our thought process doesn't get interrupted. These things assist a lot in this regard. Okay, right, good. If we already see this now, what does this mean? If we've got a cyclic quad with these lines produced and they meet at T, so what information does it tell us? We know that angle S3 is equal to angle Q1 plus Q2, exterior angle of a cyclic quad. Likewise, R2 and 3 must be equal to angle P, exterior angle of a cyclic quad. That's the interpretation of those two statements, right? RE is a tangent. Yes, R is a tangent to the circle at R, okay, with E on PT, and yeah. Okay, if this is a tangent, what information comes to mind? 10 chord. This angle must be equal to that angle. Okay, 10 chord theorem. All right, so again, annotate cleanly so that you can see. Now the other thing now is that there's PT, okay, RE parallel to OQS. Now that angle is also equal to this angle. So okay, those are corresponding angles. Nice. Now folks, we can already see that RE bisects. You see, RE bisects angle SRT. You can be asked a question like that prove that. Okay, so there's lots of questions we can ask, but once the diagram gets a bit busy, maybe one more, we can see that if this is parallel lines, so these are alternate angles. All right, and if this is the case, guys, it's already confirming that SR is equal to QR. Those are angles subtended by equal chords or angles opposite equal sides. Isosceles. I say busy cool. Let's leave it. So 10.2.1, it says prove. Yabona. Do you see? Interpreting things. So iqalaphi? Siqala ngo-tan chord theorem. You see, most we're going to start there and say tan chord theorem. So we know that I'm an R2 is equal to Q2. All right. Tan chord theorem. But o batla hore se ke tsholo man, mamela tshwere taba tse monate. Ke tseba hantle hore R2 o lekana le angle S2 ke eng? Ke di alternate angles ka baka la hore QS yena o parallel le mang? Le RE. Ke o jwetsitse ka go bana taba tsena ke tse dingata monna, dula fatshe ke tlo tshollela tsona kaofela. Le wena ha o no tseba go di etse jwang, o tla tsamaya le wena o seba ka ntle kwana. Right, what are we trying to prove? We're trying to prove that man, Q2 can be equal to S2 kaloku. Xa kunjalo, this one is because each is can be equal. R2. That other reason is not really important. Now, if this is the case, guys, we are done. We can now make the conclusion that indeed QR must be equal to RS. We can say opposite. We can just say these are the sides opposite equal angles in triangle QRS. If you like, you can just say these are angles, these are the chords opposite equal angles. I don't know, chords subtending equal angles. You can just say chords subtending equal angles. I mean, there's many reasons, but I think this one is much safer and much more sensible. Otherwise, the proof is finished. Okay, but so this statement, hey, and reason is quite strong. I want a masnapapi. Maske sitinje, one. That conclusion had to come up in the reason. Can just be now that one, RST. RST. Where is RST? Okay, there is our triangle RST. PQT, the nice blue one that we outlined. Seyigqibile nayo le. In triangle, RST and triangle PQT. What is the stories? We know that angle T is common, right? Second, those lovely stories of exterior angles. So from RST we know that S3, the car I drive, is equal to PQR. Okay, what is this? Exterior angle of a cyclic quad. Ne? The other one, look, if you prove two kodwa ke guys, mna andiwaste ixesha lam ndibe ndiyoprove ezinye izinto. It's a waste of time. From here, we know that sigqibile RST is similar. Congruent. Zawubethwa. Triangle PQT. Ke di-reasons tsa hore saprova two bafethu sigqibile. Esithathu ayidingeki la. It's not important. One, xa sithanda apha for 4 marks, so it's statement and reason. This is powerful. The final reason. Gqityiwe le nto le. Noba ungathini, noba omnye umntu angathini, uyaxoka, konta akazayithetha. Uzawuhlala phansi amamele qha. Now this one is trying to be the suplex. I mean, Lesnar retired, it seems. So who's going to give us the suplex? City. The one that is trying to replace him there is not make sure he's too dramatic. You know, sometimes when you're going to play that kind of a role, you must not be too dramatic. Yeah, so unfortunately, our brother there is too dramatic for my liking. You know, that kind of drama quickly wanes away. As a, you know, when you want to play this unstoppable force, you need to be a little subtle. You must be subtle. Not be too obvious, but you must deliver. You see, that guy, the way he's doing things, is going to hurt himself. He's going to have a short career. He just needs to restructure how he does things. Even Roman Reigns was not really attractive because he was too dramatic. So people didn't feel it. I mean, look, people were too dramatic, guys. They entice you once, the second time, say they are Kenya, straight. If I'm too papa forward. I'm too papa forward. So quickly, is what they want him. What I go, unfortunately, ndiyanifundisa so ke ngoku ninyanzelekile nimamele nithande ningathandi. PQ over PT. PQ over PT. That is the big triangle. So we know that if we proved similarity, singayitsho le ndaba. Rekayibulela taba na PQ over PT. So we can do this. It's perfectly allowed. But now we look, what is the side corresponding to PQ? In the other one, it's RS, right? Right, is RS. Right, why? Because they are opposite the equal angles. Now, what should be the side corresponding to PT? The one that corresponds to PT. PT is opposite that one, and that one is equal to that one, is RT. Yo. Okay, we've got the left hand side, but wena uvelaphi? Aske siyokutrace SE over ET ufana nabani? Ufana nalo xa edityaniswa nalowa. Ayiva kula triangle STQ with that RE parallel, we can use the proportionality theorem. So ke ngoku ithi lento yayifake ngoku u-RS ngoba siyamazi bu-RS vele ulingana no-QR. Siyamreplace. Yho, ininzi ingxaki yethu phaa. Masike siqale phaa kanye kule ndawo sithi this implies that PQ over PT kanene u-RS uyafana no-QR over RT. Yayiva ke ngoku, yes, we can say RS is equal to QR. Proved above. Besiyivile. Sibe sesithi ke ngoku kodwa bekukhona omnye umba apha ebesifuna ukhe siwushere nani. Sithi besiyiqonda straight into yoba laa QR over RT. Hayi man, besimazi kakuhle bulingana no-SE over ET. Okay, this is the proper theorem with SQ parallel to RE in triangle QST. Yabona? Ithethe into ivakala, mangathethi ngamanqampunqampu. Asifuna amanqampunqampu wendaba, sifuna indaba egcwele. Yayiva ke ngoku, now do you see what's cooking? Hayi man, there's this guy. Kiyani. So that means we are replacing, therefore, PQ over PT is indeed equal to SE over ET. Again, because it's replacing QR over what. Asafuna bese sichaza ke ngoku. Uba ngaba uyibona imarker, hayi ambofaka izibheks. Bakhona dzekedzere bamahlo. Oh, asifaka ngereason sobethwa sibulawe apha. Ayikwazi ungabikho kaloku. So you can just say similar triangles. Which ones? In 10.2.2. Oh guys, I'm feeling dizzy. Excuse me. So ayebafethu, the revision is is clear. So we're getting 5 marks. We can say statement and reason. It's quite powerful, is it not? The replacement, yeah. Statement and reason, yeah. And then the final replacement. Great you. 5 marks in the bag, guys. So for a very tasty 20 marks. And for a grand totale of 150 maraka. The maraka tsekana. Kitsebuhlokwa. So that's the one, guys. So I'm not gonna make it any longer. It's already a standard 3 hour some change video. So please, folks, as I said, if you want to make use of this, provided you've been watching the other videos in the channel, you are at liberty to pause the video each time I get to a new question. You try the question quickly and then you let the video play and you start to check how the reasoning aligns nicely with everything that's necessary. I do hope this helps for those who are unprepared, but perhaps know enough to just latch onto this car and move along nicely. But for those who are clearly lost, yeah, I sympathize with you guys, but it will be okay. Just go and give it your best. Sometimes in life, not all of us are at the same level of functionality and ability, and even luck for that matter. We just have to trust the process and trust the one above who controls everything, and also be honest with ourselves. Have we done our homework? Have we done our work? Did we do enough to say, well, this was beyond our reach? If it doesn't go well, could we beat ourselves on the chest and say we've earned it if we get it right? Or is it going to be purely luck? Hey, there's a lot we can say, folks, but at the end of the day, the work is done. Good luck for an exam tomorrow and beyond. If you watch this video before your trials, maybe that would be useful. And for those who are going to be doing their mid-year exams, the new matriculants of 2026, this may be very helpful as well. And for those who would be looking to upgrade next year, this video might still be relevant. Even in the next 5 years, this video will still be relevant. So give it a thumbs up. Okay, share with your friends. You might even want to consider subscribing. You might consider subscribing into the channel so that at least it grows a bit. Yeah, it has gone stagnant, but yeah, I know why, and it's okay. But let's keep pushing, guys. Let's not let this resource founder, because it will founder if you don't support it. You will be looking for it one day and you will not find it. So you might as well make use of it maximally so that it can grow. Remember, the growth will depend on your participation. Right. One little comment will make this look very important and relevant. Even a thank you is good enough. You don't have to say anything big and fancy, but you can even ask a question or request something. You know, all of those things make a little bit of sense. A bit of a like as well pushes up the video into, you know, the ones that can be suggested regularly. Sharing, again, it also shows that, I mean, you get the things. So folks, the algorithm works nicely, especially with the likes. So just be honest and be fair. Don't just watch and not leave a like. At least leave a like if you don't want to do anything else. Alright guys, thank you in advance as you like the videos and all the videos in the channel. Just to help out other kids, folks. I honestly don't benefit anything from these videos. I am not intending to, but I'm intending to give back to society through the young ones who still have a potential to surpass me and all that I'm capable of doing, and for our nation to move forward. Otherwise, peace out.